this problem and we're able to finish that problem, isn't it? Problem, look at example 3.1. Please mute yourselves now, mute your microphone so that we can hear and hear.
Now mute everybody. Please mute everybody.
What do you want us to do to start all over? I said you should go to your colleague. They will help you out. We can't start from chapter 1 now. We cannot do that. We're in chapter 4 today, so help yourself by contacting your colleagues. They will help you out. So we will soon be logged out now. So you are wasting time. All right? So we are going to do inverse and LU decomposition. Matrix A, you can see matrix A, right? A1, 1, A1, 2, A1, 3, A2, 1, A2, 2, A2, 3, all right? When we wanted to do gas elimination, we multiply to eliminate A21, it was X1. First of all, eliminated X1 from A21 and A31. All right? And then when we finished, we eliminated A22 prime, A33 prime. We finished that, and then we had an upper triangular matrix. All right? So that's what we are going to do, but we may not do as we did last time, step by step. You've already known the steps, so we are going to use it here. To eliminate X1 from A21, equation 4.1b. Equation 4.1b. So we multiplied equation 1 by A21 over A11 and subtract the result from the second row, A21. So we eliminated X1 there. All right? So next thing we did was we eliminated X1 from equation 4.1c by multiplying the first row by A31 over A11. A31 over A11, all right? And then we subtracted the result from A31, that's the 4.1c, all right? So when we finish that, we had, for the first step, we had, I'm still admitting people, so that's why I'm getting, but we'll be fine. So the final step was we eliminate X2 from this row here, from the last equation, 4.1c. We eliminated X2 here, and we multiplied it by A32 prime over A22 prime. That's what we had here. And we're able to eliminate the X2 from here. So we had a triangle that we're seeing here. So A11, A12, A13, A22 prime, A23 prime, A33 prime. So this is the upper triangle we are talking about. So now what do? We want to form the lower triangle. Now, if you watch, because of the eliminations we did, we are substituting the factor we used to eliminate X1 here and to eliminate X1 here, all right? And to eliminate X2 here. We put the factor, you can see the factors, A32 over A22, A21 over A11, A31 over A11. Those are the factors here. So F21, F3, we put the factors here. We will get the values when we start working with the examples. So this is how the matrix now looks like. All right. So now, what is going to happen is this. We have seen the upper matrix. We want to see the lower matrix. This is the upper matrix. We want to see the lower matrix. Of course, you say, actually, this matrix in fact represents an efficient storage of L and U, the composition. So A is decomposed into L and U. This is U through gas elimination method. Now, what we do now is, watch, this is L. How do we formulate L? That's the most important thing in this very chapter, the LU chapter. How do we formulate the matrix L? Because matrix A, we got it from the elimination using gas method. Okay, using gas method. All right, so now we want to formulate L. All right, I want to formulate L. L is, look at, the diagonal of L is 1, 1. Notice that. The diagonal of L is 1, 1. And then those factors which we use to eliminate x1 here, x1 here, x2 here, we put the factors, the three factors here. That will form the lower triangular matrix. You can see it. All right? So when we have done that, now we will try to find another intermediate vector, D. This vector D, we want to find an intermediate vector D using L, the lower triangular matrix, and the given B. I want to state here that for this LU, we are not touching B. We're only touching the matrix A. A11, A12, A13. That's what we thought. We did not touch the constant B, the right-hand constant. But what we are going to do now, we now also bring those values as if we actually modified those values B1, B2, B3. You will notice it later. So what we do is we will find this intermediary or intermediate vector D. And this intermediate vector D will be exactly the same value of B that we modified when we are doing Gauss elimination. I will show you how that will come up to play. All right. So if we put L and D, we'll get B. All right. And then we'll get, if we solve for D, look at how to solve for D. We are going to do it. Don't mind all these equations. We are going to do them numerically. This is when you are using MATLAB program. We use equation 4.7. All right. So when we calculate D, we will now use, when we calculate D, we will now use the values of D with the upper triangular matrix. All right, the upper triangular matrix. Then we use it to calculate the unknown. We use it to calculate unknown with the D calculated. Then we do back substitution, which will give you the xn. And then we substitute back again as we did in gas elimination. That is how we do this. I want to quickly go back and and explain it. I want to quickly go back and explain it. Let me go back. All right. Let me go back quickly. I'll run it faster now. So we have this equation 4.1. We want to apply the LEU decomposition algorithm. How does it work? All we are going to do is we want to decompose this matrix A into matrix L and U. L is the upper triangular matrix, U is the lower triangular matrix. When we apply gas method, gas elimination to this matrix A, we will have upper triangular matrix equation 4.2. And you know how we know how we got to that place by eliminating x1 from equation 2 and equation 3. And then for the first column, and then for the second one, we eliminate x2 from the last equation. All right, and we'll get this matrix equation 4.2, which is the upper triangular matrix. All those factors, F21, which is A21 over A11, used to eliminate X1 from this point, and then A31 over A11 used to eliminate X1 from this point, and then the A32 prime over A22 prime, see A32 prime over A22 prime used to eliminate X2 from here. We will keep them so that we can use them to formulate the lower triangular matrix. Look at how the decomposed matrix looks like actually. So this is the F21, F31, F32, A22, A23, A33. That is the matrix. So these values, if we put them here, this is how it's going to look like. So replacing the 0 elements in the above matrix gave the modified matrix A. So this is the matrix A modified.
Sir, please, your screen is not.
What?
You can't see it clear.
It's clear now.
You can't see the
Your screen is not too clear.
It's clear. Oh, it's clear.
Yes,
It's clear.
you can
It's
see
very
it clear.
You have to adjust. You have to adjust it on your phone. The screen is not the desktop. Adjust it on your phone.
You can also zoom it. You have a desktop. You can zoom it by your step.
Let's use
everyone and give us a.
Let me see if I can zoom it here. Trying to zoom it.
It's okay like this.
Yes, sir, you can zoom it by yourself.
Sir, it's very clear.
Use your text.
Actually, is this
Okay, you can zoom it. Zoom it.
Yes.
So let
You
me
can
zoom
zoom
it
it by
so
yourself.
that we don't create trouble here now. It's coming up in my own.
No need. Just carry on like this.
Is it okay now?
It's okay.
It's even very big.
All right. I see people coming.
It's okay.
Okay. All right. So let's move on so that we can understand quickly what we are talking about. So this is the upper triangular matrix. Let's formulate the lower triangular matrix. Let's formulate it. So to formulate the lower triangular matrix, we use all those factor F21. You know F21 is A21 over A11, and F32 is A32 prime over A22 prime. You put them in this matrix, but let the diagonals be 1, 1. The rest will be 0, 0. So this is your lower triangular matrix equation 4.5D. All right. So we move on now. We want to move on to another step. After the decomposition, a solution can be obtained for a particular right-hand side vector B. Okay, this is done in 2 steps. 1, forward substitution for D. We want to calculate D as an intermediate. This involves generation of an intermediate vector D using L, the lower triangular matrix 4.5, times D. We are going to generate the element of D using the constant B that we are given. We didn't modify it in this case. So when we do that, now we have D. Now we use D and U to find X. All Right? We are going to see it numerically. We do back substitution using U, X, and D. These values of D will automatically be the values of X of the right hand vector modified as if we applied Gauss elimination on B. All right? So having done that now, we want to apply equation, this method to example 4.1. Watch what is happening. Solve the following set of equations with LU decomposition. That is equation 3x1 minus 2x2 plus 3x x3 equals minus 10. 2x1 plus 6x2 minus 4x3 equals 44. Minus x1 minus 2x2 plus 5x3 equals 26. We want to solve this equation using LU decomposition. That is the equation given. All right? So, we do elimination, right? You know, we are not going to repeat order. We do elimination. You know how to do elimination? F21, right? To eliminate x1 from the first equation, right? We multiply the first equation. For the second equation, we multiply the first equation by this constant or that factor. Look at the factor up there. Look at the equation. You are seeing the equation. If you have your book, you'll be looking at the book. So to eliminate x1 from this equation, that's what we are going to do. We are going to use the factor a21 divided by a11. That is 2 over 3. So we multiply the first equation by 2 over 3. Simplify it, we will have 2x1. And the result that will come out, we subtract it from this equation. We will eliminate x1 the way we've been doing before. We do the same thing here. So this factor here is F21, while this factor here is F31. And what is the value of F31 is minus 1 over 3. And we multiply equation 1 by minus 1 over 3, right? And subtract the result from the last equation. We will eliminate x1 here. Both of them are gone. And so here we will be having A22 prime, A32 prime. There must be values here. So, and then we will eliminate x2, from equation 3, leaving this equation as standard equation. Okay? And the value will be A32 prime divided by A22 prime. That will be F3. Let's look at what I just said here now. Because we have done it, we are not going to repeat all that. So when you do the first elimination, x1 is second and third equation, this is what you have now. So this one will be A22 prime, A32 prime. Okay, that's what we are now. We want to eliminate x2 from the third equation. All right, our time is running out. We will don't forget how we usually do it. Don't forget, when the time runs out, we will come back. Okay? We will come back.
Thank you for coming back.
Let's see what we have. So this is A22 prime, A32 prime. So we want to eliminate x2 from the third equation. It will be A32 prime 1.3333 divided by minus 7.3333. That's what we are going to do. You can see it F32. So it is 1.333 divided by minus 7.333. And then we subtract the result from this third equation. When we do that, see what we have. Minus 5.51517 x3 equals that minus 13.4547. So this is an upper triangular matrix now. This is upper triangular matrix now. Watch. You have minus 10, minus 50, minus 22, right? We have modified this. This is done to show you an example. As example, what we want to show you, that when we calculate D, we are going to have minus 10, minus 50, and minus 13. We are going to have those values. All right? Let me still admit some people. Admit all. Unmute all. All right. Okay. So look at putting the equation together. Let's forget about the right hand side now, b that we multiply. We will show you something. So you have, this is the upper triangular matrix. 3 minus 2, 1, all this one, 0, 0. We have this and we have that. All right? Let's see. We have, this is not 0 here. It's not 0 here. It is minus 7, 3, 3, 3, 3. That's what will be here. Okay? Just notice that error there now. Now, that is upper triangular matrix. Okay? So let's formulate the lower triangular matrix. We said the diagonal will be 1, 1, 1, right? Diagonal is 1, 1, 1. Then 0.666 is the F21, which is 2 over 3. We use to eliminate x1 here. All right? And the other one is minus 1 over 3, which is this value here. And then F32 is that, this value here, 832 prime over 822 prime. This value here is 1.33 divided by minus this. That is the value you have here, minus 0.1818114. This is the lower matrix. You see how we formulated the lower matrix? That's the most important thing here, to get the lower matrix. As a matter of fact, if you multiply this lower matrix with the upper matrix, this is not 0 here. This is minus 7.3333. Please make sure you correct it in your book. So I'm saying that if you multiply this and this, you will have, go back and get A. You go back and get the matrix A in 4.1. All right. Now let's now calculate the intermediary matrix D. That intermediary matrix D will give all these values. I want to show you. We give all these value of B multiplied. We give all this minus 10, minus 50, minus 30. Watch out now. Watch out now. We are not supposed to do this, but I just did this to show you what we will get. All right? So look at it. We will calculate D1, D2, D3 using the lower matrix, and then the given B, constant B, the right-hand side B, originally given, not modified. It is minus 10, 44, and 26. Let us see it so that you will understand what we are saying. I have 4 minutes. Let's see the...
Sir, please, how is the...
See, the matrix A. You can see the matrix A. The right-hand side is minus 10, 44, and minus 26. We only multiplied it just to show you something. But as you do it, you don't modify it. We want to show you that you can calculate the modified values. Let me show you the modified values of B when we apply the Gauss elimination. You see the modified minus 10, minus 50, minus 50. That's what we are going to get now. So watch out. Watch out. Using D and original B given. That is original B given. We want to calculate D1, D2, D3, which will give us the modified B using Gauss elimination. So if you use this equation, we want to calculate D1. D1 is D, look at how we do it, D times 1 plus 0 times D2 plus 0 times D3 equals minus 10. Hello, is D1, all right? 1 times D1 plus 0 times D2 plus 0 times D3 equals minus 10. So when you simplify, you have D1 equals minus 10. Then we will now solve for D2 in the second equation. The second equation is 0.6667 D1 plus D2, right? Plus D3, which is 0 times 0 times D3, which is 0. That's why I don't have D3 here. So when you simplify D2, right? When you simplify, you can add this one here and simplify this. So look at it. But let's see the other one. The equation, third equation is minus 0.333 times D1 minus, see it, minus 0.181814 D2, right, plus D3 equals minus 26. So when you simplify all the D's, you have that D1 is minus 10, D2 is 50, and D3 is minus 20.210. That gives you the values up here. Look at the modified, the up there. So these are the values, all right? These are the values. It's supposed to give you these values by right. It's supposed to give you these values. There may be some errors there, all right? Let's use our calculator. We can use our calculator. If D1 is that, so we can put D1 here, multiply D1 here, all right? Multiply D1 here. You have 3 minus 3.333. D1 is minus 10 to be plus. So you move it to this place. So to be 29 point something, right? So it will be plus 29. So minus will actually give us plus instead of. So somebody with a calculator can do and find out the true answer. All right?
Please, sir, I'm lost somewhere.
Don't be lost. Just keep going. We'll come back.
Hello, sir.
Don't be lost.
Okay.
So I just want us to calculate the values of D1, D2, D3. All right? So we will have, if you put the value of D1 into there, you have the value of D2. Okay? The value of D2. All right? Then it's for, okay, the D2 is 44, sorry. So it's 60 times D1 times